So good afternoon, everybody. Thanks for joining in to our last webinar of the series. It's on external historian support. And with us, we have Xavier Mesrubin, who's VP Sales and Marketing. He's got quite a lot of insight into this topic, working with quite high-end customers around the globe. So first thing first, the logistics. You are currently on mute. If you have any questions, then you can, within the chat or the question window, you can ask us the questions and we'll accommodate them as and when we get time in between the presentation. If you've got any questions of concern, just give us just send us a message. Copies of the presentation and webinar will be emailed to yourselves. So the agenda for today is what are the external historians supported by DataHub? How do we achieve secure data aggregation? And then how do we get the data through the DMZ? As you all know, according to the NIS2 directive, more and more control systems are being deployed using the DMZs. And then for no data gap solutions, what is the store and forward, and how do we apply that using our solution? The first thing first, the supported historians with DataHub's new external historian feature are the InfluxDB and also the InfluxDB Cloud. So if you want to send the data directly into the cloud, then you can do that via DataHub. Amazon Kinesis, which is a historian solution by Amazon Web Services. You can do the Aviva Historian, formerly known as Wonderware Historian, and also the new cloud-based solution, which is the Aviva Insight. So you can send the data directly to Aviva Insight in the cloud. And last but not least, we do support natively OSIsoft by Historian. So you can connect to it and store your data locally or over the network. What we've also added to this new functionality is the ability to store data into Historian using REST APIs. Xavier will be touching on that in a brief moment. So what data sampling do we support? We support first, last, mean, min, max, min and max. This is just the commonly used data sampling, and we support all of it. And for any solution to be robust, it has to have a forwarding strategy. So you could locally buffer the data, and whenever the client side or the other networking side is available, you can then tunnel the data through or send the data through to the remote historian. The first thing first, how do we actually securely amalgamate or aggregate the data from the production system, right? So you get the data, you've got multiple machines, multiple lines, you've got multiple assets that are generating this data. And then you want to get that data into a single data set securely, and then send it across to historian. So Xavier, if you could just kindly take us through how DataHub securely transmits the data across a network.
Thanks, Abdul. Good afternoon, everyone. I'm Xavier Mesrubin. Let me explain, and I'm sure most of you are familiar with tunneling solutions or the ability to tunnel data using OPCDA or a tunneler product. DataHub is very unique in the sense that we don't tunnel, we mirror. We call it tunneling. We actually call it tunnel mirror. And so how the process works is actually quite simple. The DataHub acts as an OPC client or a Modbus, I guess, master to the data, collects the data, creates a unified view of that data, and then publishes that data to a data user. Now that data user could be a DMZ, it could be a cloud provider. In either case, it's an outbound connection. So it's pushing data through, it's mirroring the data at the data user. The DataHub can also be configured bidirectionally. So in essence, I can actually mirror the data in both directions. So if the data user changes a set point or changes data, it can also be mirrored back into the source. The core here is that we are not opening up any inbound firewall ports. And so it's an outbound connection to the data user. There's no VPNs required. It's real time, so it's highly robust and highly scalable. How's that, Abdul?
Yeah, perfect. And for this concept, the secure OPC connectivity concept, we've done a whole webinar on this. That was the first webinar of the series. So that link will also be shared with yourselves. If you're more interested in knowing that, then that you can view that in your own time. And if you've got any questions, you can always get in touch. But Xavier, nowadays, because of the NIST-2 directive, there has to be an air gap or a divide between the OT and IT. How does DataHub scale to that?
So one of the great advantages of the DataHub is that its mirror capability can work in both a hub and spoke, or it can work in daisy chain. And so one of the core components is that ability to do daisy chaining. And so if we look at connecting, for instance, OPC DA, we can now create a connection from the DA server into a centralized server in the DMZ. The data is mirrored. And then from there, we can publish, or I should say the IT can connect into the DMZ in order to collect that information. And again, the data is mirrored in the IT. So you can see this whole daisy chain operation. But DataHub's not limited to just OPC DA or OPC UA or Modbus or A&E or ANC. It can do databases as well. We can also connect data from other historians. And so the net result is that now we can connect to a database. We are pushing or mirroring the data to the DMZ. At the DMZ, it's creating a unified view of the data that any subscriber, whether it's IT or whether it's going to be a cloud instance or wherever that instance is, they would be able to access the data that they are able to get to when they're able to get to it. And the same applies with OSI Pi. Again, we can collect from the OSI Pi data, bring it into the DMZ, and then share it if we need to with other constituents.
And I believe the beauty of this is that with the tunnel/mirror functionality of DataHub, you are actually transporting real-time data.
Correct. We are transferring real-time data.
Yeah, and that actually, when you dig and the functionality that is inherent into the DataHub, when you're transporting real-time data through a daisy-chained system, it is very reliable.
Correct.
Can you add anything to that?
No, it's truthfully because our technology is really based on this concept of separating the network layer from the data layer. And so should the network go down, the DataHub will reestablish a connection in milliseconds, which is very unique in the industry in that most tunnelers would wait for what's called an OPC fail. And that could be anywhere between 30 seconds to 5 minutes, depending on who your vendor is. Whereas with the DataHub, any fail in the network, partial or full, the DataHub will try to reestablish its connection. So very reliable connection.
Well, thank you very much. I've got a question, but the question is really about one of our attendees couldn't join our previous webinars. So we will be sharing the links to the older webinars that we've done. They're around OPC, secure connectivity, and the best practices. Plus, the second webinar we did was how to build a cloud connection or a cloud solution using DataHub. And what are the best practices around that? So yes, the answer is yes. We'll share the slides as well as the videos that we've done. Now, Xavier, coming to the external historians, we've established the fact that we've got native functionality built into DataHub that we can communicate to a local instance of an external historian. But how do we scale it when you have a remote instance of external historian and you would like to send that data across the network? And you don't want to lose any data, how would you do that?
And so how the DataHub handles that is we have a purpose-built implementation of InfluxDB, and it is designed as a on-site historian with limitless possibilities, which means that you can store as much data as you want for as long as you want. And how the system works actually is that the data is processed into the historian first and then fed from the historian to the connecting network. And so in this particular case, we're showing that we're connecting to OSI Pi. But if the connection between the tunnel failed, so what would happen is the data would actually be stored locally on the OT network until such time as the connection is reestablished, and then it will backfill into the Pi historian. So really no loss of information. The key here is that the connection is native to OSI Pi, and you know, I talk about OSI Pi, but in fact, it can be a native connection to Aviva, Insight, it can be to Kinesis, it can be to any of the historians that we offer, even, you know, IoT gateways for that matter. So we can do store and forward to the IoT gateways. At the end of the day, what it really comes down to is that the client doesn't lose the data. And as long as they don't lose the data, they can run their analytics with confidence, if you will.
That's great. And what I would bring the focus to is that with this configuration, you don't need any inbound firewall ports open to the OT network, which means you're not actually exposing the OT. You're not creating any attack surface. So, you know, from the IT network or from the cloud that can penetrate into your OT network and harm your production facility, right?
Correct.
And that's a big plus. We don't only populate the external historian, but we do that in a secure way.
Correct.
Right. Again, we can scale that solution via the DMZ. So yeah, Xavier, so if you just briefly explain this, how do we achieve this solution?
So the DataHub, again, because it supports daisy chaining as well as hub and spoke, I can actually have multiple locations connected to the DMZ. And so I can have multiple sources of data mirroring into my InfluxDB database. And then that data can then be funneled or, you know, brought right into the external historian endpoint, if you will. And so there's really no limits in terms of the data because we're not putting any limits on our connections. Really what it comes down to is the size of the machine that's actually doing the aggregation from that point. So scaling the product is very easy. It's just a matter of having multiple connections.
Yeah. We've discussed DMZ in quite a lot of detail in our first webinar. We speak about OPC security. And the good thing about this is that we can scale that with no data gap solution. So along the daisy chaining or the hops we've got here, we can buffer or store and forward the data. So there's no data gap when you have the data in the OT site. Then when you take the data across the network to a DMZ, you can still store the data and buffer the data, and that would give you a complete data set, right? So you don't lose any data there when you're sending the data or populating the data onto an IT network or a cloud system.
Correct.
Which is great. I don't see any questions, but if you have any questions around you know, security or historians or store and forward, then kindly ask. So what I would say is, in a recap, Xavier, if you just in a nutshell explain that how external historians make life easier for our users, for customers.
Sure. So the first one is that, obviously everybody does want to store their data into an external historian. So from a local connection, you'd have a simple solution. But if you're moving data from a control network to an external historian, which is located in IT or in a DMZ, because obviously most companies are moving away from keeping the historians in the control network. One of the challenges that you have is really that you need to have the external historian read into the control network. So that's opening up an inbound firewall port. Typically, sometimes you can actually have the historian use an agent to pump it into the historian, but the DataHub automatically incorporates that agent, so you don't have to extend into it. The same thing applies here is when we start moving into more of a store and forward with an isolated network. At each one of these hops, there is no inbound firewall port on the plant network, the DMZ. There's no inbound firewall port there is an inbound firewall port on the DMZ, but the IT network or the edge, or not the edge, the destination is going to set up a tunnel connection to the DMZ. So it's an outbound from the IT department to the DMZ, but then the data is going to be mirrored. So it follows the exact same principle that we do with our mirror capabilities, but as opposed to mirroring real-time data, we're mirroring it in terms of the historian. The destination, though, is really the critical component, because as more and more companies move to the cloud or Azure or Amazon, they want to be able to put their historian in Amazon or connect to other services. And really, this is the piece that we really take it to the next level. We most recently announced, for instance, the DataHub as an Azure managed service. So now we can actually have a DataHub running in Azure, connecting and mirroring that data from the plant, subscribing to other services, and bringing that data back at the plant level where they need the analytics or where they need the results.
Great. Xavier, I want to invite you to share your screen and show how easy and simple it is to configure. So I'm just going to make you the presenter here. Right. So you go ahead and share your screen now.
Should be able to. Hopefully everybody can see my screen.
I can. So I hope everybody else can.
So just a really quick recap. So what you're looking at is DataHub version 10. This is the latest version that will be coming out shortly. What we have is the DataHub is constructed in, think of it as plug-in architecture. So each of these are licensed items. So I've clicked on the external historian. I want to take a look at what the external historian setup looks like. And you can see that from here, I can choose my external historian, whichever one it is. And so a couple of things. So there's your Insight, your Kinesis, your InfluxDB version 1 and 2, SciPy, REST clients. Tunnel, push, and pull, these really relate to this concept of if I'm pushing data or if I'm pulling data. So that has the instance of when we're talking about mirroring data across DMZs. Retention policy, as I said, the retention policy is really defined by how you define, how much disk do you want to put in, how many days do you want to retain the data. And so think of it as a giant wheel. Data goes in, and then as it expires, it gets released. And so you've got this cycle of data that's keeping. Abdul talked about data sampling. I can enable data sampling, and in the sampling, I set up my intervals. I can set up the type of my sampling I want, min, max, minimum. I can ignore bad quality data. I can sort the data by timestamp. And then finally, when we talk about this concept of historical forwarding, when I enable it, what it does is it asks me for a strategy. And that strategy is defined in another settings to say, look, what data am I collecting? What strategy? What's my time? The time in which I'm going to collect that data. And lo and behold, that sets up the strategy. And then finally, when we talked earlier about this concept of, connecting multiple endpoints, so I've got multiple endpoints into one central DMZ, I want to have a unique forwarding ID client. And so I can have multiple instances connecting into the same client and bringing that data in, or I could have unique databases of each one and then bring them across. So hopefully that answers your question, but ultimately from here, I can choose the data points I'm looking for if I'm not using a strategy, and lo and behold, everything takes care of itself.
Perfect. And data sampling is all about pre-processing the data at the edge, and then sending all the relevant information rather than all the information that is being generated at the plant source. Is that correct?
That's correct.
Right. So, thank you, Xavier, for your demonstration. I'll just take the presentation again. Can you see my screen now?
I can.
Perfect. So I think we've covered almost everything that we want to talk to you about today. But last thing is all about DataHub. DataHub doesn't only have external historian, but it also supports OPC, all the flavors of OPC with TCP, Modbus TCP, MQTT. It acts as an MQTT broker as well as a client. And when we talk about the client, it can publish and subscribe. And as a publisher, it has got the IoT gateway where you can publish the data directly into Azure IoT Hub, Amazon Web Services, and Google IoT. And also supports any ODBC compliant database. So you can get the data from the database, or you can put the data into the database if you're not using the external historian. I so far have no questions, Xavier. Is there anything that you'd like to add?
No, the only thing I'd say is give it a try. You'd be surprised at how easy the DataHub is to use. And I can assure you, once you've tried using our tunneling product, you'll see that by far it exceeds most everyone's expectations. So I welcome you to give it a try and download it right from our website.
Okay, great. I would like to thank everybody who's attended the webinar, and I'm sure people who have not been able to attend will be interested in. So I will be sharing the PowerPoint and the recording of this video. If you have any questions, any application that you'd like to discuss, we can have a one-to-one session. Just drop an email or give me a call, and we can arrange that. So once again, thank you for your time, and you have a good day, and speak to you soon. Thank you very much.
Thanks, everyone.